On behalf of the USDA Natural Resources Conservation Service, the Georgia Soil and Water Conservation Commission, the Upper Chattahoochee River Soil and Water Conservation District, and Schnabel Engineering, we thank you for your interest and participation in this third public meeting for the Supplemental Watershed Plan Environmental Assessment of Settingdown Creek Dam number 59. The purpose of the planning study is to assess the Settingdown Creek 59 watershed, to evaluate the performance of the existing watershed structure, and to develop a plan to address compliance issues that are identified as a result of the evaluations. Also, the planning team will determine if federal financial assistance will be available to address compliance issues, as well as if the project sponsors would like to continue operation of the dam within the NRCS watershed program. Public participation is of great importance to the planning process. The objective is to inform the public and watershed stakeholders of the planning effort. The planning study requires a series of public meetings. The first and second public meeting presentations included a brief history of the NRCS watershed program, a brief history of dam safety, considerations for the design, operation, and maintenance of dams, an overview of the Settingdown Creek watershed and the specific dams that are included in the planning study. And at the end of both of the first two public meetings, the public was given an opportunity to submit questions and comments regarding scoping topics, project opportunities, and concerns. The second public meeting included a list of potential rehabilitation alternatives to address concerns or compliance issues with the dam. The first public meeting was available on Schnabel's YouTube channel from August the 7th until August 17th, 2020, and the second public meeting was made available from December 18th, 2020 until January 4th, 2021. Please note that the first and second public meetings for this dam have been reposted to Schnabel's YouTube channel for those interested in viewing the presentations and the content described above. During this third public meeting, the following topics will be discussed: an overview of the Settingdown Creek watershed and the dams that are being studied currently, a review of the existing conditions associated with the Settingdown Creek Dam number 59, a description of the three shortlisted alternatives to address compliance issues with this dam, and an opportunity to submit questions and comments regarding the planning study and the alternatives described in this presentation. The Settingdown Creek watershed is located in northern Forsyth County, Georgia. Settingdown Creek is a tributary of the Etowah River, which flows into the Coosa River near Rome, Georgia. The watershed contains over 34,000 acres of drainage area. The original watershed work plan, prepared in the early 1950s, provided for the construction of 15 floodwater retarding structures, which are known as the Settingdown Creek dams. This slide shows a map of the Settingdown Creek watershed with the delineation beginning at the confluence of Settingdown Creek and the Etowah River at the left side or western side of the view. The watershed boundary is delineated in red, and key highways in northern Forsyth County are indicated for reference. This slide presents a map of the watershed overlain on aerial photography from the early 1960s, which would have been taken shortly after the completion of construction of the Settingdown Creek dams. As you can see, the watershed land uses in the 1960s have changed over the past 60 years to what we know today. As part of the supplemental watershed planning process, upstream areas of the dam were assessed for flooding, as well as to determine the need for additional storage capacity in the lakes. Also, downstream areas with regard to flooding and hypothetical breaches of the dam were evaluated. The hydraulic capacity of the existing spillway outlet works was assessed during a variety of storm events. The economic and social benefits provided by the dam were quantified, and an assessment of environmental and cultural resources was also performed. Once again, here's a map of the Settingdown Creek watershed. The dams that are currently being studied as part of the planning process are indicated along with their subbasins. As you can see, most of the dams in the study are located at the upstream end or eastern end of the watershed. We are also studying one dam near the western or downstream end of the watershed as part of this planning study. Settingdown Creek Dam number 59, which is the subject of this presentation, is a dam that meets Georgia Safe Dam Program criteria to be considered a Category 1 or high hazard potential dam. This means that failure or improper operation of the dam would likely result in the loss of human life. The dam requires an operating permit from the SDP. Previous assessments indicate that the dam does not comply with current Safe Dams Program rules and requirements. The dam is not exempt from these rules, and a purpose of the planning study is to determine if federal assistance will be available to bring the dam into compliance with current dam safety requirements. The Safe Dams Program is fully aware of this dam, its classification or pending classification as a high hazard dam, and that the dam is being studied by the planning team. Some original features associated with the design of the dam are that the dam was not originally designed as a high hazard dam. Development has occurred downstream of the dam, requiring changes to the original hazard classification of the structure. The purpose of the dam is flood mitigation, and a secondary purpose is sediment accumulation and storage. The dam includes a reinforced concrete principal spillway system composed of a riser structure located in the lake on the upstream side of the dam with a nearly horizontal pipe or conduit that conveys water from the riser structure through the earthen embankment and to the outlet channel at the downstream end of the dam. The dam also includes a vegetated earthen auxiliary or emergency spillway that is designed to pass flows associated with low frequency, high intensity storm events. Here's a map of the watershed once again with the location of Settingdown Creek Dam number 59 and its subbasin highlighted in yellow. As you can see, dam number 59 is one of the upstream-most dams within the Settingdown Creek watershed. The dam is located adjacent to the Hampton Golf Club, south of Glen Haven Drive. Construction of the dam was completed in 1954, and the dam appears on the National Inventory of Dams with a surveyed height of 33 feet. The drainage area at the dam is approximately 1.8 square miles, and the design storage capacity of the dam is 586 acre feet, and that storage accounts for sediment storage below the normal pool elevation of the lake, flood storage between the normal pool elevation and the auxiliary spillway control section, and surcharge storage between the auxiliary spillway control section and top of dam. Here's an aerial photograph taken in the 1950s, which also indicates the location of the dam. As you can see, There's been no development adjacent to or upstream of the dam in this aerial photograph. Fast forward to today, and there are some notable changes: the development of the golf course and some residential communities around the lake and upstream of the dam within the watershed. As part of the planning process, a limited topographic survey was performed of the dam. This survey included elevation shots on the dam crest, along the principal spillway system alignment, and within the auxiliary spillway channel. For reference, just note that the dam has been cleared in this aerial photo. The dam was cleared during the summer of 2020. The riser structure is the gray square located in the top right portion of the lake shown in this view. There's a blue line that indicates the alignment of the principal spillway conduit through the dam, and the auxiliary spillway for this dam is located just to the right of the principal spillway alignment between the dam and the residential homes on the right side of this view. This slide shows a topographic site plan of the dam. For reference, we're showing the principal spillway riser structure and pipe, along with the alignment of the auxiliary spillway. As you can see, the properties at the right side are immediately adjacent to the auxiliary spillway channel. Also, the approximate limits of wetlands that were delineated as part of the environmental survey are indicated downstream of the dam at the top of the page. The lake would be toward the bottom of this view. We have a couple of photographs of the dam. This photograph is taken from the left abutment area at the crest, looking toward the principal spillway system and the residential homes. Indicated on this photo are the crest of the dam where the golf cart path is located. The riser structure, the concrete structure, is also indicated in the lake, and the upstream slope of the dam where the dock projects is also shown on this photograph. This photograph is taken from the downstream slope of the dam. As you can see, the downstream slope is in the foreground. The concrete principal spillway conduit outlet is indicated, and the riprap lined plunge pool is also shown in this photograph. As part of the planning study, an environmental survey of the dam and its vicinity was conducted. The aquatic resource survey exhibit shown here on the left side of this slide indicates the limits of the survey area, along with the locations of streams, wetlands, and open water identified by the environmental survey team. Invasive species in the form of Chinese privet were also indicated on this exhibit. The environmental survey found no protected species during the performance of the survey work. A phase 1 cultural resources survey was also performed of the dam and its immediate vicinity. The cultural resource survey map on the left side of this view shows the location of survey transects and shovel tests that were performed as part of the survey. In addition to the field survey, a literature review of the project area, the dam area, was also conducted. No archaeological resources were recorded as a result of the survey work. The dam, being greater than 50 years old, is technically eligible for the National Registry of Historic Places, but its listing on the registry is not recommended. The dam, although it being old, is not a unique or notable feat of engineering or construction. There are several other flood control dams, hundreds to be exact, in Georgia and across the United States. So its historicity is not unique and doesn't merit listing on the Registry of Historic Places in the opinion of the Cultural Resources team. The team concluded that no additional cultural resource work is recommended for this dam or project site. As part of the evaluation of downstream areas, a dam breach inundation study and mapping were performed. This slide indicates the limits of a hypothetical sunny day breach of the dam. The inundation limits are indicated in blue, and the locations of potentially impacted structures are also noted with the red house symbols. Please note that the dam is located at the right or eastern end of this map, and the breach flows would progress in generally an east to west direction along this map view along Settingdown Creek. In addition to the breach analysis, downstream flooding analysis was performed for the 2-year through 500-year storm events. The 100-year and 500-year storm limits are indicated on the map in yellow and purple respectively, along with structures that would be impacted in the event of these levels of flooding. The limit of study is shown at the left side or west side of the map, and the flood analysis for the frequency storm events was terminated just downstream of the crossing of Settingdown Creek at John Burris Road. In addition to the downstream analysis, upstream flooding evaluations were also performed as part of the planning study. You can see the location of the lake and the dam at the bottom middle of the map view, and the extents or contours associated with the normal pool, auxiliary spillway, and dam crest elevations of the dam and lake are shown on this map. In addition, maximum water surface elevations associated with the 100 and 500-year storm events and the Georgia Safe Dams Program and NRCS design storm events are also shown on this view. Homes or structures with finished floor elevations within 10 feet of the top of dam elevation were surveyed as part of this planning effort. And as you can see, the lowest homes are included on this map. However, none of these homes are impacted by upstream flooding associated with the dam. They are all located higher than the anticipated maximum water surface elevations that could be experienced at this structure. A review of some of the existing deficiencies with Settingdown Creek 59. As stated previously, the dam was recently cleared during the summer of 2020 and is revegetating. An underwater inspection of the riser structure concluded that portions of the slide gate assembly are worn or corroded, meaning that the gate operating system will likely need some attention. Portions of the riser concrete are cracked and or spalled, and a closed circuit television inspection of the interior of the principal spillway conduit resulted in a review that showed that the pipe is in acceptable condition and can be used in the future in its current condition. With regard to hydraulic deficiencies, during the Safe Dams Program design storm event for the dam overtops by 1 foot and the auxiliary spillway breaches. With regard to NRCS hydraulic criteria, The auxiliary spillway engages prior to the principal spillway hydrograph storm event, which is an evaluating storm event for auxiliary spillway locations. The principal spillway conduit is incapable of meeting drawdown requirements. The auxiliary spillway is over 4 feet lower than what is required by NRCS standards. And during the NRCS design storm event, which is 100% of the probable maximum precipitation, which would be on the order of 30 or 32 inches of rain in 6 hours, the dam overtops by 4.3 feet and the auxiliary spillway breaches. In light of the deficiencies with the dam, the planning team has shortlisted 3 alternatives for addressing issues with the dam. These alternatives, which will be described in further detail, include a no action alternative, which would not take advantage of federal funding and would require that the dam be upgraded or breached in accordance with Georgia Safe Dams program criteria for a high hazard dam. The planning team is required to consider a decommissioning alternative, which would be a complete removal of the embankment, stabilization of the excavated channel and resulting lake bed, and also consideration to flood proofing or relocating downstream interests. The final alternative that will be discussed in today's presentation is the future with federal investment alternative, which would entail a full NRCS rehabilitation of the dam to meet those requirements. It would involve improvements to the embankment, removal and replacement of the principal spillway system, and the construction of a new auxiliary spillway capable of passing the required design storm events. We note that during the development of the NRCS rehabilitation alternative, consideration was given to upstream non-flood control ponds, as well as uncertainties associated with climate change. So the first alternative that we'll discuss today is the no action alternative. This would be if the federal interest in the project expired and the project sponsors were required to comply with Georgia Safe Dams program requirements or regulations. The planning team looked at 2 options for this. One would be removal of a portion of the dam and permanent draining of the lake, or rehabilitating the dam to Safe Dams standards. Given the amount and quality of downstream interests, including residences, a public library, road crossings, etc., the planning team determined that to remove the dam would put too many structures at risk of flooding, and that the more cost-effective alternative for the project sponsors would be to rehabilitate the dam to Safe Dams program standards in this scenario. So this alternative would involve raising the dam crest, upgrading or regrading the upstream and downstream slopes of the dam, constructing a wave berm with riprap along the shoreline, and decommissioning the existing auxiliary spillway by filling it with compacted earth material. The principal spillway system would be removed and replaced with a new riser structure. The existing pipe could be reutilized, but it would need to be extended to accommodate changes to the embankment and the riser structure. A riprap line plunge pool would be also constructed at the downstream end of the new pipe, or the extended pipe, excuse me. To pass the Georgia Safe Dams program design storm event for this dam would require a reinforced concrete labyrinth crested chute spillway with a total width of 60 feet. That would be composed of 2 30-foot wide cycles. We'll show you briefly some photographs with an example of what a labyrinth crested spillway would look like. The spillway would be constructed over the earthen embankment, and consideration would be given to providing access to both sides of the spillway As we noted before, there's currently a golf cart path that crosses the crest of the dam. So any alternative such as this would need to include some sort of consideration to keep that cart path and access in service. The spillway would have a reinforced concrete stilling basin at the downstream end with a riprap lined apron to transition flows from the concrete portion of the spillway to the natural stream channel. Also note that this large spillway would not flow on a regular basis. It would only flow in the event of low frequency, high intensity storms greater than the 100-year and 500-year storm event. Here's a site plan with the layout for the Safe Dams program rehab. As you can see, the principal spillway riser structure would be moved further into the lake to get the wave berm with riprap constructed along the upstream shoreline. The pipe would be extended. New principal spillway plunge pool would be constructed, and the 2-cycle labyrinth spillway would be constructed over the embankment. This view indicates that we would have a ramp going down from either side of the dam crest, and access could go around the upstream end of the labyrinth weir to provide access to both sides of the dam. As mentioned before, this spillway would not flow on a regular basis. The normal pool would be established by the riser structure and the pipe, and the auxiliary spillway, in this case the labyrinth spillway, would only flow during large storm events. The planning team had to assess a decommissioning alternative for the dam. This process would involve removal of the majority or all of the existing embankment along with the principal spillway system. The floodplain would be reconnected. The grade of the floodplain would be reconnected to its original form prior to the dam being constructed, and the lake bed would be stabilized with vegetation, and the primary channel through the old dam would be stabilized with riprap. Decommissioning the structure would improve flooding upstream of the dam. As we stated earlier, there's really nothing that's impacted upstream of the dam by flooding, but the downstream flood benefits, which are great in this case, would be lessened or lost. As part of the decommissioning alternative, the planning team evaluated and quantified the downstream benefits currently provided by the dam, as well as what the loss of those benefits would mean to those downstream interests. Here's a site plan of what the decommissioning alternative would look like. This alternative would require the complete removal of the dam. Consideration would have to be given to how the cart path would be addressed in this alternative. As you can see, we're showing the riprap through the primary channel where water would flow on a regular basis, but that's kind of what the site plan would look like. Here's some examples of a dam removal to give you some perspective on that. You can see large portion of the earthen embankment has been removed. The excavation slopes have been stabilized with matting and vegetation, and the primary channel through the dam has been stabilized with stone riprap. The final alternative that we'll talk about today is the future with federal investment. This alternative would allow the project sponsors to enter into an agreement with the federal USDA NRCS to cost share the rehabilitation effort for this dam. This alternative would be similar to the no action alternative required, except a little bit larger. The dam would need to be raised to accommodate the 100% of the design, 100% PMP, which is the design storm for the NRCS. The upstream and downstream slopes would need to be regraded. The wave berm would need to be installed, and the existing vegetated auxiliary spillway would be decommissioned. A new riser structure and extension of the principal spillway pipe would be performed. and a new plunge pool would be constructed at the downstream end of the conduit. Similarly to the no action alternative, a labyrinth crested spillway would be required. Given the intensity of the design storm in comparison with the Georgia Safe Dams program design storm, the NRCS labyrinth spillway would need to be larger and would have a total width of approximately 136 feet and be composed of 4 cycles. That would put it at approximately 34 feet per cycle. The spillway would be constructed over the embankment. Consideration would be given to providing access to both sides of the spillway from the dam crest. The spillway would also have a stilling basin, a riprap lined apron to transition flows from the concrete spillway to the natural stream channel. Here's a site plan with a layout of the new spillway. You can see some similarities with the no action alternative. The major difference is the size of the labyrinth spillway, as well as the height, the raised height of the dam would be a little bit higher in this case too. Here's the profile view of the spillway. As you can see, as I said previously, this spillway would not establish the normal pool elevation of the lake. It would only engage in the event of larger storm events in excess of the 100-year and 500-year storm events. We've got some photographs with examples of labyrinth spillways. This is a 5-cycle labyrinth spillway that's been constructed over the crest of a dam. This spillway has a bridge that could be an option in final design for this spillway. It would be a cost consideration for the sponsor, but there is the opportunity to put a bridge over a labyrinth spillway if that is desired. But you can see that this labyrinth spillway actually establishes the normal pool elevation of this lake. This would not be the case for Settingdown 59. However, the layout of the spillway it would be similar. Here's an example of a labyrinth spillway that only engages in excess of the larger storm events, the 100-year, 500-year storm event. This is an example of a spillway layout as well, where access from one side of the dam to the other is accomplished by going around the upstream end or the top side of the spillway, as this view is shown. You can see also the location of the riser structure in relation to the spillway for this particular layout. Based on the results of the planning study and discussions with the project sponsors, including representatives of the Soil and Water Conservation Commission and the state NRCS, the locally preferred alternative for this dam is being presented as the future with federal investment alternative. This would be rehabilitating the dam to meet NRCS criteria and take advantage of federal funding to do so. The dam would be raised, a new principal spillway riser structure would be constructed, and the larger 4-cycle labyrinth spillway would be constructed over the crest of the dam with this alternative. This alternative takes advantage of federal funding, and based on the cost share percentages would be the most advantageous from an economical perspective for the project sponsors. As stated at the beginning of the presentation, the public interest and participation in this project is very important to us. We invite project stakeholders to submit questions and comments regarding the development of the plan and the alternatives discussed today to us for consideration. Questions, concerns, and comments may be submitted by accessing a Google form at the web address provided here. This link, please note, is not clickable or accessible in the YouTube video. However, If you look in the comments section directly below this video, a clickable link should be available. If the clickable link, if you have trouble with it, the address, the HTTPS address, can be typed into a internet browser address bar to access the Google form. So if you need to pause the recording at this time and write down the link address, feel free to do so. The planning team will accept questions and comments associated with this public meeting. This is actually the third public meeting through Monday, July the 19th. So please take advantage of the opportunity to submit questions and comments so that they can be considered by the planning team. This concludes the presentation associated with the third public meeting for Settingdown 59. Thank you once again for your interest in the project and your participation in this meeting. And we would encourage you to submit your questions and comments regarding this study in a timely manner so that they can be considered by the team. Thank you once again.